the students. I am Dr. G. Hima Bindu from the Department of Mechanical Engineering, and I will be dealing the subject robotics in Institute of Aeronautical Engineering. And today's topic is problem solving on trajectory planning. So firstly, let me read out the question first and explain how the solution will be done, right? So the revolute joint of an articulated PTP robot which traverse from an initial position of 100 to 400 and the final position in 3 seconds. We to assume a 3-degree polynomial and start off acceleration at 3 degrees per second. Determine the declaration at the end of the 3 seconds. Right? We need to determine the declaration at the end of 3 seconds. So how will we solve this problem? Right? We already know the 3-degree polynomial equation. So assuming that equation, we need to find out the declaration at the end at 3 seconds. So here already we have theta 0 is equal to 100 and theta 3 is equal to 400. This is being given in the data. And initial acceleration is theta dot of 3 is equal to 3 degree per second square, right? We need to know the final velocity, that is theta of 3 is equal to 0, because the system come to a stop at 3 seconds. We also know as the velocity is also 0 because the system comes to stop at 3 seconds. So first let us write down the equations for velocity and acceleration. In order to derivate the theta of t, we need to write down the equations for velocity and acceleration. So as we know, the velocity equation is a1 plus 2a2 t plus 3a3 t square, and acceleration is 2a2 plus 6a3 into t. So already we know a0 is 100 and theta of 3 is equal to 300. Theta dot of 3 is equal to 0, that is nothing but a1 plus 6a2 plus 27, a3 is 0. A theta of 0 is equal to 2a2, that is 3 seconds. Right? From the condition 4, we can write a2 is equal to 3 by 2, which is nothing but 1.4. Right? From these particular conditions, from this particular equation 4, we have got a2 value. Here also we need to find out a2, right? So we have got a2 value as 1.5. Now substituting this particular a2 value in condition 2 and 3, right? Substituting the a2 values in condition 2 and 3, what we are getting? 100 plus 3a1 plus 9 into 1.5 plus 27a3 is equal to 400. When we are solving that, this is the equation which we have got. 3a1 plus 27a3 is equal to 286.5. Now for condition 3, from the condition 3, a1 plus 9 plus 27a3 is equal to 0, where we are equating a1 is equal to 27a3 minus 9. This is the equation which we are getting for condition 3. Now substitute 2 from equation 1. We need to substitute 2 from equation 1, that is 2a1 is equal to 295.5, where a1 we are getting as 295.5 by 2, which is nothing but 144.75. This is the value of a1, right? So here we have got the a2 value as 1.4, a2 is equal to 1.5, a1 is equal to 147.75. In the same way, substitute a1 value in equation number 3. So what we are getting? We will be getting a3 value also. a3 value will be equal to minus 5.8. So from this equation, we are getting a3, which is nothing but minus 5.8. That is 227a3 is equal to minus 156.75. That is minus 156.75 by 27, which is nothing but minus 5.8. We have got a3 value also. So here we have determined a1, we have determined a2, and we have determined a3 with the help of the velocity and acceleration equations. Right? So theta of 3, the declaration at t is equal to 3 seconds, we need to find out. So theta of 3 is equal to 2 of 1.5 plus 6 of minus 5.80, which we are getting it as 3 minus 34.8, which is nothing but minus 31.8 degrees per second. So the declaration at the end of 3 seconds is nothing but 31.8 degrees per second square. Right? Hope you have understood this problem, how we have found the declaration at the end of 3 seconds. Next, moving on to the second problem. On the joint of an articulated robot has to travel from an initial angle of 200 to the final angle of 840 in 4 seconds. Initial angle is theta of 0 is equal to 200 and final angle theta of 4 is equal to 840 degrees. The time is 4 seconds. Under a 3-degree polynomial calculation, calculate the joint angle of 1, 2 and 3. So the equation is theta of t is equal to a0 plus a1t plus a2t square plus a3t. So theta of 0 is 200, theta of 4 is 400, theta of theta0 is 0, theta of theta4 is 0. So as per the velocity equation, right, as per the angular velocity equation, a1t plus a2t plus a3t cube is. So when we are substituting these values using the boundary condition, that is theta of 0 is equal to a0, which is nothing but 200, or theta of 4 is equal to 200 plus 4a1 plus 16a2 plus 64a3, which is nothing but 840. This is already given, right? But the angular velocity at 0 is nothing but 0, and velocity at 4 is nothing but 0 plus 8a2 plus 48a3, which is equal to 0. Right? So from this we have got a1 is equal to 0. From the condition 3, right? From the condition 3 we have got a1 is equal to 0. Now as a1 is equal to 0, when we are substituting that in either of the equation, that is in 2 or 4, we will be getting 200 plus 16a2 plus 64a3 minus 840, or we can write 16a2 plus 64a3 minus 640, or we can also write as 4a2 plus 16a3 minus 160, that is taking out common, right, from the equation 1. So for this particular condition of 4, we write 8a2 plus 48a3 is equal to 0, where it is a2 plus 6a3 is equal to 0, taking out 8 as common. Right? So when we need to solve the equation of a2 is equal to minus 6a3. Right? a2 is equal to minus 6a3. Substituting the value of a2 in the equation 1, we have got 4 of minus 6a3 plus 16a3 minus 160. That is minus 24a3 plus 16a3 minus 160. Or it is, when we are taking common, 8a3 plus a3 minus 160 is equal to, where a3 is equal to minus 20, right? Where a3 is equal to minus 20. a4 we have got, a1 we have got, and a3 we have got. Now substituting a3 as minus 20 back in equation number a2, we will be getting a2 is equal to minus 6 of minus 20, which is nothing but 120. So the polynomial equation will become t of t is equal to 200 plus 120 t square minus 20t cube. Substituting all these values, what we have got, t is equal to 1, t is equal to 2, and t is equal to 3 at 3 seconds. It is nothing but theta of 1 is equal to 200 plus 120 of 1 square as 200 into 1 cube, which we are getting it as minus, which we are getting it as 300. And at t seconds, we are getting t of 2 as minus, we are getting it as 520. And at 3 seconds, theta of 3, we are getting it as 740. So at theta of 1 is equal to 300, theta of 2 is equal to 520, and theta of 3 is equal to 740. Right? At 3 seconds, we have got theta of 1 is equal to 300, theta of 2 is equal to 520, and theta of 3 is equal to 700. Right? So this is how we solve this problem. Moving on to the third question. A single link robot with a rotary joint is motionless at theta 0 is equal to 150. It is desired to move the joint in a smooth manner to theta of f is equal to 750 in 3 seconds. Find the coefficient of cubic that accomplish this motion and bring the manipulator to the rest at the goal. That is, at the end goal, we need to get the manipulator at the rest. So again, for that, the angular velocity equation is theta of t is equal to a0 plus a1t plus a2t square plus a3 t cube, where theta of 0 is equal to 150, theta of 3 is equal to 750, angular velocity at 0 is equal to 0, angular velocity at 3 is also equal to 0. So this is the given equation. Now in the initial position, what is the value? Theta of 0 is equal to a0 plus a1 of 0 plus a2 of 0 square plus a3 of 0 cube is equal to 150. And at final position, it is equal to 750. So velocity angle, how we have got 0 is theta of t is equal to a1 plus 2a2 plus 3a3, where we are getting it as 0. The final velocity, how we are getting 0, that is a1 plus 2a2 of 3 plus 3a3 of 3 square is equal to 0. Now from this we have got a0 is equal to 150. That is a1 is equal to 0. At the initial position, a0 is equal to 150 and the initial velocity a1 is equal to 0. Now with these equations, we need to substitute that in. This 750 minus 150 plus 0 of 3 plus 9 is 2 plus 27 a3, which is equal to 600 minus 9a2 plus 27 a3, where we have got 200 is equal to 3a2 plus 9a3, right? So when we are solving this, we have got a2 plus 3a3 is equal to 200 by 3. 200 by 3, where it is equal to 0 is equal to 0 plus 6a2 plus 27a3, where it is nothing but 2a2 plus 9a3 is equal to 0. So the two equations are a2 plus 3a3 is equal to 200 by 3 and 2a2 plus 9a3 is equal to 0. Now multiply the first equation with 2. So what we are getting? 2a2 plus 6a3 is equal to 400 by 3. Or we will be waiting for the 2a2 plus 6a3 minus 2a2 plus 9a3 is equal to 400 by 3 minus 0. So this is how we are getting the equation. So here a0 is equal to minus 400 by 9. And with respect to the first equation, a2 plus 3 of minus 400 by 9 is nothing but 200 by 3. And the final equation for a2, we are getting it as 200. Right? So the cubic polynomial equation, we already know theta of t is equal to 150 plus 0 into t plus 200 into t square minus 400 by 9 into t cube. So theta of t will, by simplifying this particular equation, we will be writing theta of t is equal to 150 plus 200 square minus 400 by t cube. That is, therefore, these are the coefficients, that is 150, and at 750 in 3 seconds, bring it to the rest in the final position. Right? These are the references which we have gone through. Right? So in today's class, we have gone through 3 problems on the cubic polynomial, on the equations of cubic polynomial. Hope you have understood how to solve the problems when they are being given on the cubic polynomial at the initial and the final positions. Right? So this is all for today. Signing off for today, Dr. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.